Dear students, now we solve question number 21 from the question series of IIT JAM 2024 mathematics question paper. The question is, for PQR are real numbers where r not equal to 0 and n a natural number, let an is equal to p to the power n, n to the power q, n by n plus 2 whole n square, and bn is equal to n to the power n by n factorial r to the power n into root over n plus 2 by n. Then which one of the following statements is true? Option A, if 1 less than p less than e square and q greater than 1, then the series an is convergent. Option B, if e square less than p less than e to the power 4 and q greater than 1, then the series an is convergent. Option C, if 1 less than r less than e, then the series bn is convergent. And option D, if 1 by e less than r less than 1, then the series bn is convergent. So let us try to solve this problem. Here an is equal to p to the power n, n to the power q, n by n plus 2 whole to the power n square. Here we apply Cauchy root test. So an whole to the power 1 by n is equal to p to the power n whole to the power 1 by n into n to the power q whole to the power 1 by n, and n by n plus 2 whole to the power n square to the power 1 by n is equal to p to the power n into 1 by n, that means p, into n to the power q by n into n by n plus 2 whole to the power n is equal to p into n to the power q by n into 1 by 1 plus 2 by n whole to the power n. Now limit n tends to infinity, an to the power 1 by n is equal to limit n tends to infinity p into n to the power q by n into 1 by 1 plus 2 by n whole to the power n is equal to p into limit, since p is a real number, so p into limit n tends to infinity n to the power q by n into limit n tends to infinity 1 by 1 plus 2 by n whole to the power n is equal to limit n tends to infinity n to the power q by n is equal to limit n tends to infinity n to the power 1 by n whole to the power q. So for q greater than 1, limit n tends to infinity, n to the power 1 by n is equal to 1. So p into 1 into limit n tends to infinity 1 plus 2 by n whole to the power n. Let 2 by n is equal to t. Then n is equal to 2 by t. Therefore t tends to 0 as n tends to infinity. So limit t tends to 0, 1 plus 2 by n is equal to t. So 1 plus t, n is equal to 2 by t is equal to limit t tends to 0, 1 plus t whole to the power 1 by t whole to the power 2 is equal to this limit is equal to e. So the value of the limit is e square. Therefore from here p into this limit is 1 and this limit is 1 by, because this limit is e square, so 1 by e square is equal to p by e square. So by Cauchy root test, the series an is convergent if limit n tends to infinity an to the power 1 by n, if this is equal to L and L must less than 1. Here L equal to p by e square. So p by e square less than 1. Since p is a real number, then for any value of p less than e square, summation an is convergent. Hence summation an is convergent if p less than e square, for any value of p less than e square. So it must if p 1 less than p less than e square and q greater than 1, because for q greater than 1 this limit is equal to 1. Therefore in option A, if 1 less than p less than e square and q greater than 1, then the series an is convergent. And from here we see that an is convergent if 1 less than p less than e square and q greater than 1. Therefore option A is true and option B is false. Now you have to find the range of R for which the series Bn is convergent. So from the series Bn. Here Bn is equal to n to the power n by n factorial r to the power n root over n plus 2 by n. So Bn plus 1 by Bn is equal to n plus 1 whole to the power n plus 1 into n plus, this is 1 plus 2 by n, so 1 plus 2 by n plus 1 whole to the power half by n plus 1 factorial into r to the power n plus 1 into Bn means n to the power n 1 plus 2 by n whole to the power half into n factorial into r to the power n. So this is equal to n factorial, n plus 1 factorial means n plus 1, r to the power n in this means r. So this is equal to n plus 1 into n plus 1 whole to the power n, n plus 1 whole to the power n plus 1 means n plus 1 into n plus 1 whole to the power n by n plus 1 into r into n to the power n into 1 plus 2 by n means n plus 3 by n plus 1 into n by n plus 2 whole to the power half. N plus 1 cancel is equal to 1 by r into n plus 1 by n whole to the power n means 1 plus 1 by n whole to the power n into n plus 3 by n plus 1 into n plus 2 whole to the power half. Now limit n tends to infinity Bn plus 1 by Bn is equal to 1 by r into limit n tends to infinity 1 plus 1 by n whole to the power n into limit n tends to infinity n into n plus 3 by n plus 1 into n plus 2 whole to the power half. This is equal to 1 by r, and this limit is e, and this limit is equal to 1, because if we divided n square numerator and denominator, then we get the limit is 1. So this is equal to e by r. By ratio test, summation Bn is convergent if limit n tends to infinity Bn plus 1 by Bn is equal to e by r less than 1, that is e must less than r. But from here, in option C and D, in option C r less than e, but we see that e less than r. So option C is false. And option D, you see that 1 by e less than r, but from here we see that e less than r. So option D is also false. Therefore option A is correct. Thank you.